In a certain city, this is day 34, review of conditional probability. In a certain city, 45% of registered voters are Republicans, 40% are Democrats, and the rest are independents. Also, what we know about the Republicans, 40% of them are women, 55% of the Democrats are women, and 60% of the independents are women. So make a tree diagram to display this information.
Okay.
So what are the three types of things you could be? Okay, so the probability that you're a Republican is what? 0.45. The probability that you are a Democrat is 0.4. And the probability that you are an independent is 0.15. So, in each of these groups, can you be a male or a female? So the probability that you are, we'll call it female and not female. How's that? Probability of being a female if you are a Republican is what? 0.4. Okay, the probability that you are not a female, you can call it male if you want. I'm calling it female complement. Okay, what is the probability that you're not a female if you are a Republican then? 60. If 40% are females, how many have to be males? Okay, so now if you're a Democrat, what's the probability that you are a female? 0.55. And so then what's the probability that you are not a female? 0.45. 55% of Democrats are females. The rest of them have to be males. Okay, finally, the independents, the probability that you're a female is
0.66.
And so the probability that you're not a female independent is 0.45. So if I've got lots of branches to follow, thank you, it's 0.40. Jake, everybody fails the test because of you? You'll take all the points they missed off yours.
What if they service it?
Well, they might. Don't mess them up anymore on the notes. Okay, so now, what is this? If I follow this branch, I'm finding the probability of what?
That you're
Republican and a female, so that would be 0.45 times 0.40. What's that?
0.18.
Okay. And what's the next branch? The probability that you are what? Republican and not a female. So that would be 0.45 times 0.60. Well, we'll just round all of these to 2 since we started. We'll be consistent. So this one is the probability that you are a Democrat and a female, which is 0.40 times 0.55. Point what? 0.22. Are you trying to win? Is that our goal? We're trying to win?
Yeah.
Okay. So what's the next probability is the probability of what? Democrat and not a female, which would be 0.40 times 0.45. I got to hear you.
0.18.
Thank you, 0.18. All right. And the next one is the probability that you are an independent and a female. Okay, so 0.15 times 0.160 is 0.09. And the probability that you are an independent and not a female is 0.15 times 0.40, which is 0.06. So all of these probabilities should add up to what? 1. They do. There's 40, 50, 60.
70, 80, 90, 100.
Yep, there we go. Thanks. Thank you very much. Okay, so now we're going to answer all these questions. Suppose that you randomly select one registered voter. That's good, because selecting 2 would not be so much fun.
0.8.
So what is the probability that you choose a person who is a Republican and a woman? So the probability that you choose a Republican and a female. 0.18. Did we? Yeah, it's right there in our tree diagram. There it is. Republican and a female, 0.18. All right, what is the probability that you choose a person who is a woman?
Add up 3.
Okay, add up 3 of them. So which 3 are you going to add up?
First.
Republican and female? Or you could be
Republican or Democrat. Female.
you could be a Democrat and a female, or you could be a independent and a female. So you're just going to add up, or means plus. What 3 numbers are you going to add up here? 0.18 plus 0.22 plus 0.09, because those are the three probabilities that have females. So that would give you 0.49. All right. So in other words, of the whole population, 49% are women. So what percent would be men? 51. Okay, that wasn't a real question on here. So, okay, so next one. What is the probability that you choose a person who is a male? Probability that you, in other words, choose female complement, or the probability that you just choose an independent? Okay, well, so what is the probability that you, for this one? What ones are you going to add up for this one?
And both the independent.
You're going to add up the three male things, so there's three things that are males. Okay, so you're going to add up 0.27 plus 0.18 plus 0.06, so that's going to be the probability that you are a male. And then you're going to add up all the independent ones, right? So all the independent, well, aren't just the independents there, 0.15 already? So plus 0.15 minus, why minus, Jake? They,
A male and an independent.
yeah, can't you be a male and independent? So you have to subtract, you have to take out you have to subtract the probability that you are a independent and a male, which is what probability? 0.06. So you have to add all of those and then take away 0.06. What do you get? 0.6? Okay. All right, so part D, what is the probability what is the probability that a randomly chosen male is a Republican? Okay, what kind of probability are we doing now? Regular?
Conditional.
Conditional. What do we know then? If it's conditional, what do we know? So we know he's a female complement, male. And what do we want to find the probability of? Republican. So what would we calculate? What would be on the top? The probability of what? Republican and a female complement divided by the probability of female complement. Okay, so the probability that he is a Republican, what's that? He. I said he, that meaning male. Point what? 27.
Oh,
Okay. Divided by just the probability that he is. Okay, now watch. Didn't we find that right here?
Yeah.
So isn't it just the sum of those three that's going to go down there? And Trevor, what are you saying?
0.51.
0.51. Okay, so that's good. So now the final probability, we divide those, and that should give us
294.
can I call it 5.3? Okay, since I started rounding by to 2 decimal places here, that's what I just kept doing. Okay, now our next question is, are being a woman and being a Democrat independent? Okay, so the probability of B given A is equal to the probability of just event B. So what do you want your event B to be?
Democrat.
So you want that to be Democrat, given that they are a woman, okay? And so then the other side, the question mark is that the same as the probability of just being a what? Democrat. So we need to find these two probabilities. So the probability of being a Democrat, given that you're a female, would be calculated by taking what?
0.22 divided by 0.49.
Okay, well, I'm going to write the formula first. So the probability of being a Democrat and a female divided by the probability of being a female. So the probability of being a Democrat and a female, 0.22, divided by the probability of being just a female, we did that in part B, 0.49. So those two divided give you 0.45. And we want to know, is that the same as just the probability of being a Democrat? So how many are Democrats?
0.4, so we're
0.4. So this one, the question, it's a question. Are they equal?
They're not within 3%.
They're not within 3%. So we're going to say based on our level of accuracy that
It is.
that they're not equal. We're going to say they're not equal. So they're not equal. They are.
What I'm saying is independent.
No, if they're equal, they're independent.
Yeah, that's what I said.
If they're not equal, they are not independent. So being a Democrat and a woman, being a woman, I can't even spell being right now, being a woman are not independent. In other words, what that means, it means your gender affects your choice of political party. Being independent means they don't affect each other. If they're not independent, it means your gender is affected by, or your party, political party is affected by your gender. That's what it means. All right, so now it says it's possible to use a table to solve this problem, but it takes more work to construct. So you know what? We're not going to do it that way.
Okay.
So we are going to look at another problem and make a table. So we're going to move to the next page. So again, this is all just review. So we have a survey of 1,200 college students. 380 said they had tried smoking, 800 had tried drinking, and 315 had tried both.
What?
Make a two-way table to display this information. So, we have two events. We have drinking and smoking. We're going to call them D and S. So, we're going to, over here, we're going to have the drinking side of my two-way table, so I can either drink or not drink. Does that make sense? Drink or drink complement. And then along the top, I'm going to have smoking. And for smoking, they can either smoke or smoke complement, not smoke. So on the ends of this, we can put our totals if we need to. So, 1,200 college students. Where does the 1,200 go?
Total.
Right down here, 1,200. Okay, and 380 said they had tried smoking. Where does the 380 go? Bottom of what? Smoking. So that's 380. So how would I figure that number out? 1,200 minus 380, which is 820. All right, so 800 had tried drinking. Where does 800 go? The end of the drinking row. So how many have not tried drinking? 400. And so with our final number, 315, where does that go? Drinking and smoking. So how am I going to get that number? 800 minus 315, that's 485. And then how would I get that number? 380 minus 315 is 65. And I could get this number by taking 400 minus 65 or 820 minus 485. Either way, it's 335. Okay, so what is the probability that a randomly chosen respondent has tried neither? So the probability that they've tried neither, okay? Hold on. It's out of how many? All of them. It's always out of all of them unless it's what kind of probability? Conditional. When you're dealing with a two-way table, it's always out of everybody unless it's conditional. Then the condition narrows it down to one of these other numbers. So the probability that they've tried neither, that would be this number right here. So 335 out of 1,200. Okay, so if you wanted to write that as a probability, it'd be the probability of drinking complement and smoking complement. So, all right, so what is the probability that a randomly chosen drinker has also tried smoking? Well, let's see, what kind of probability is that going to be?